Hello, my name is Mr. A. Today, let's talk about geometry, part 2, area of trapezoids, and area of parallelograms and triangles. First, let's recap. For a square, you're going to have to do base times height. Because it is a square and all the sides are the same, you will do 3 times 3, which will give me an area of 9 feet squared. For rectangles, you will use the same formula. Area equals base times height. 7 meters by 2 meters will give me an area of 14 meters squared. And finally, a standard parallelogram will have one side that is not used. That side is a diagonal line, and we cannot use diagonal lines when we find area. The base of this parallelogram is 7 centimeters, and the height is 2 centimeters. We will do 7 times 2, which will give me an area of the same as our rectangle, 14 meters squared. Moving along to triangles, we have a change in formula. While the area for parallelograms, all 3 of them, the formula was area is base times height. For triangles, that formula is going to be area is base times height divided by 2. Starting from the left with our right triangle, we look for our right angle, telling us where our 2 perpendicular lines are, and we will take 3 times 3, which will give us 9. 9 divided by 2 will give us a final area of 4.5 or 4.5 feet squared. Moving on to our next type of triangle, our isosceles triangle has 2 lines that are not used, unlike our right triangle, which has 1 diagonal line which is not used. We will cross out our 2 diagonal lines so we don't use them, and we will look for our right angle, telling us where our base and height are located. In this case, our base will be 7, and our height is 2. We will take 7 times 2 to give us 14, and then we will do 14 divided by 2 to give us a final area of 7 meters squared. And finally, for our obtuse triangle, we have 1 diagonal line that is not used, and that is 9 centimeters. Off to the side, which is common with obtuse triangles, there is a dotted line forming a right angle mark. This part of the shape is not actually used in our calculation for the base, and our base is just going to be this 7 or 2 centimeters. Our base is going to be 7. I keep getting base and height confused. I don't know why. I'm not going to edit this out. I'm too lazy. The base is 2, the height is 7. Same as our isosceles triangle. 7 times 2 will give me 14 again, and 14 divided by 2 will give me an area of 7 centimeters squared. Now there is one thing I would like to point out. Each of these shapes have the same base and the same height. Our parallelogram and obtuse triangle have the same dimensions, a base of 2 and a height of 7, and vice versa, and yet the area of our triangle is exactly half, and this is because we divided by 2. The same is true of our rectangle and its isosceles triangle, and of our square and our right triangle. Let's move on to some trapezoids. Now the first way I'm going to talk about is the no formula method. While there is a formula that can be used to calculate the area of a trapezoid, there is a method of finding the area that doesn't require the memorization of a formula, but it still does require knowledge of 3 steps. Step number 1 is to remove diagonals. And that's simple enough. In this case, our 4 centimeters is a diagonal line. This is still true that we will not use our diagonal lines in order to find area. As part of step 1, as soon as you are done finding diagonals and removing them, you will have to divide your shape into 2 triangles. And the way we're going to do that is we're just going to draw one line from one corner of our shape to the other. You can do this either from this corner to this corner, or from the top left to the bottom right. This will form 2 triangles. Neither one of them are ordinary. One of them is very, very close to appearing as though it is a right triangle that is turned on its side, while the other is very clearly obtuse. Step number 2 is going to be to find the area of each of those triangles. So, I'm going to go ahead and label our triangles as triangle 1 and triangle 2, with this one being triangle 1 and this one being triangle 2. So, for triangle 1, we know that we will have to use the formula base times height divided by 2. If we look at triangle 1, it has a base of 7 centimeters and a height of 2 centimeters. So, we will do 7 times 2 divided by 2. 7 times 2 will give me 14, and 14 divided by 2 will give me 7. This is just for triangle 1. This is not our final answer. For triangle 2, we will use the same formula, base times height divided by 2, except this triangle has a different sized base. The base of this triangle is only 3 centimeters, while the height, although it's a little difficult to see, will stretch from here all the way down. And that is the same as the height for our other triangle. They share a height. So, we will do 3 times 2 divided by 2. 3 times 2, of course, is going to be 6, and then 6 divided by 2 will give me an area of 3 centimeters squared. Now, unlike our parallelograms, where cutting it with a diagonal line will result in 2 equal triangles that are exactly half of the size, these triangles will not be the same size. The triangles you have will give you different areas. At this point, you will have to follow the third and final step for finding the area of the trapezoid. And that third one is to add both areas. So, we will take our 7 centimeters squared and our 3 centimeters squared, add them together to get our final area of 10 centimeters squared. That's all there is to it. At the end of the video, I will show you a secondary method that I did not go over in class today, which does use a formula specifically for a trapezoid. But we'll get to that later. For now, we're going to practice a couple of problems. We'll start off with one of our homework assignments. Question number 4 is a stereotypical trapezoid. It has 2 diagonal lines that we are going to have to remove. That is going to be 3.8 feet and 3.9 feet. Next, we're going to draw our diagonal line in order to form two triangles. We're going to label them triangle 1 and triangle 2. And at this point, we can get started. Off to the side, we're going to go ahead and find the area of triangle 1. Triangle 1 has a base of 7.3 feet and it has a height of 3 feet. Triangle 2 is a little bit different. It has a base of 2.5 feet, although I don't really have to write the feet, do I? Triangle 2 has a base of 2.5 feet, and it has a height also of 3 feet. If we check over it, the base is 2.5 and the height is 3. At this point, we can go ahead and start solving them. It's important to remember that this particular unit is calculator active. And while it would be nice to be able to simply solve this problem without the use of a calculator, let's not waste the opportunity. For triangle 1, we have 7.3 times 3, and then we will divide by 2. This gives us an area for triangle 1 of 10.95 feet. For triangle 2, we have 2.5 times 3 divided by 2, and that will give us an area of 3.75. The final step is we have to add those two values together. If we take 3.75 and add 10.95, we will have an area in total of 14.7 feet squared. There we are. Let's try a less conventional trapezoid, because they do exist, but the method of solving for them is the same. This shape at the bottom is also a trapezoid. It has two parallel sides and two sides which are not parallel. First, let's get rid of this diagonal line, as it will not be used to calculate area. Second, we are going to draw our diagonal line ourselves through the middle of this trapezoid. We will start at one corner and draw our line down to the other. Now, while this does not look the same as other trapezoids that we have practiced up till now, this is still giving us a triangle with a base and a measurable height. Although the height is slightly over, it is as tall as the entire shape. The same goes for the second triangle. It has a distinct base, and it shares the height of the other triangle. So, writing out those amounts, triangle 1 has a base of 8.9 miles, and it has a height of 5 miles. Triangle 2 is different, with a base of 4.1 miles and a height of 5 miles. So we will write 4.1 times 5 over 2. Finally, we will switch over to our calculator, and we will check to see what these amounts will be. We have 8.9 times 5 divided by 2, and that will give us an area for triangle 1 of 22.25. For triangle 2, we will do 4.1 times 5 divided by 2, which gives us an area for triangle 2 of 10.25. Finally, the third and final step for a trapezoid without using a formula will be 22.25 plus 10.25. And that will give us 32.5 as our final area and answer for this problem. And of course, we can't forget we were measuring in miles. Now, as stated a moment ago, there is a specific formula that can be used to calculate the area of a trapezoid. And that formula is that area equals base 1 plus base 2 divided by 2 times the height. Now let me explain the difference between base 1 and base 2. Let's say I have a stereotypical trapezoid, and it has a base down here of, we will call 10 meters. The base on the top will be 5 meters. This diagonal line we will say is 6 meters, and we will say that the height of this shape is 4 meters. Now, once again, that 6 will not be used, so we can eliminate it immediately. Using this formula, we have two bases. It does not matter which one you label as which. We will call this one base 1, we will call this one base 2, and naturally, that would make this 4 meters the height. Now, we can simply take all of those amounts, plug them into our formula, and solve. So, the area of this trapezoid will be 10 plus 5 divided by 2, and this amount will be multiplied by 4. Following our order of operations, we must take care of this first. Area equals 15 divided by 2 times 4. 15 divided by 2 is going to give me 7.5, or 7.5. 7.5 times 4 is going to give me an area of 30 meters squared. While this is a little bit more straightforward, it does require the memorization of a formula. Naturally, the no formula method will still require memorization of 3 steps. It is simply a question of, would you rather divide this shape into 2 smaller shapes, or would you rather tackle it head-on using a standard formula? I will leave that choice up to you. That's all I have for you. I hope you found this video informative, and I'll see you later.